Welcome! In this series of short videos, we will look at topics for the PowerBasic Windows compiler. Today we will look again at the creation of game utilities with our game map by adding hills and mountains to the 3D view. This was our application at the end of the last video. We have created a world map which has been displayed on the screen. The user can then click the Process Turn button to position the rulers on the map. Currently the system supports 50 rulers. On processing the bulk turns, or a single turn, the rulers will start to move around the map to acquire territory. When we click on one of the territories on the map, we have two graphics controls displayed to the user in a new dialog. The first is a small reduction of the main global map. The second is a 3D rendering of a perspective view of the terrain. The terrain in the game map at the moment has only two possible statuses. It is either sea level or it is land. We are storing this in a one-dimensional array, storing either the value 0 or the value 1 to indicate sea or land. What we're going to do today is to introduce hills and mountains. This should give our 3D map a little more realism. There is also a small bug needing to be fixed in the 3D map, whereas the right hand and bottom edges of the 3D map are showing sea level. So let's have a look at the code to see how we can do all of this. Since we're going to introduce mountains, the question is just how many mountains are we going to add to the system? To allow this to be reasonably flexible, I'm going to create a constant at the beginning of the code to specify the number of mountains. As we may want to change the height of mountains and other landmass, we want to set this as a constant as well. So here we have two new constants, max mountains, which we're currently setting to 50 for the number of mountains we wish to inject into the terrain, and 10 for the vertical offset. Setting the vertical offset as a constant will allow us to change it to improve the look of the 3D graphics map should we think it needs more vertical height. So if we locate where the vertical offset is actually used, we can substitute the hard-coded 10 for that value. The vertical offset is currently held within the determine terrain function. At the moment, it's hard-coded for the value of 10. So we will replace that with our constant to allow us to change it easily at the beginning of the application. So before we make radical changes to the 3D map, there's one little bug we have to fix, and that is the edges of the right-hand side and the bottom of the terrain map, which are currently showing as 0 in height each time the grid is displayed. Currently, the 3D map is generated inside the function that shows the terrain info dialog by calling the draw polygons terrain function. While this works well, it does mean that the graphics map is entirely generated before the form is shown to the user. For debug purposes, it would be ideal if we could slow down the drawing of the graphics map so we could see each polygon as they're drawn. In order to do that, we're going to have to use a timer on this form to delay the creation of the population of this graphics control. So if we comment out this code that currently displays the polygons, and if we go to the callback function, the event handler for this dialog. So if we comment out this section of the code, and if we place it within the callback function, the event handler of the dialog, there are two pieces of information we're going to have to store, the X and Y coordinates, which the user has clicked on and which were passed into this function as parameters. We can save these two values quite easily by using the dialog setUser command. Each dialog has 8 user values you can actually store within the dialog itself. So we pass a number of parameters during this one. The first is the dialog handle, the next is the slot into which we wish to push the value, and the final parameter is the value we want to store. Having stored these in the dialog, we can now go to the callback function. So within this callback function, we're going to declare two local variables, X and Y. These will be populated with the values we saved in the dialog. Next, we're going to create a timer which will trigger inside the initialize dialog event. We'll create this timer1 constant at the beginning of our code in a moment, but the purpose of this timer is to trigger 200 milliseconds after the dialog is displayed to the user. And we'll need to set up an event to handle the triggering of that timer. And once the timer has been triggered, we'll want to kill off and stop the timer, as we don't want it triggering every 200 milliseconds. Now we can pull back the values from our dialog to populate those X and Y coordinates by using the dialog getUser command to pull back slots 1 and 2 to the X and Y coordinates. Now we can add back in the code we commented out in the dialog. To attach to our 3D graphics control, set the scale, draw the polygons, and do the graphics redraw. Before we try running our application, we'll need to set up this timer constant at the beginning of our application. And there is our timer. If we try running our application now, it should run exactly as it did before. So next we're going to put a delay into the code which draws these polygons. So in order to see these polygons getting drawn as they are created, I'm going to comment out the redraw option on the graphics attach command. And if we nip into the draw polygons terrain, and we'll want to set in a couple of sleep commands to slow the system down enough so that we can actually see it doing something. If we put 100 milliseconds sleep in, this should do the job nicely. So if we try running our application now, click on Load Map, and click on an area. And we should now see the polygons getting drawn one at a time. So for debug purposes, this is ideal when you've got a bug in the code. You can actually step through to see where the bug occurs. So it's drawing the polygons quite happily, but it does seem to have a problem with the periphery of the graphics map. Now there's something we want to change. The dimensions of our array are both using max X. That needs to be max Y. And if we look in the load map array, we've got some hard-coded values in here we want to replace with constants. Replacing these with constants will allow us to change the size of the map later on, should we need to do so. Plus, there are a couple other changes we need to make to the map. Currently, the map handles either a 0 or a 1. We're going to have to put in values which are greater than 1. Therefore, any testing we do of the map to see whether it's sea or land, we'll need to check to see if it's not 0. So there we have a test for the map checking to see whether it's 1, to see if it's a land area. We can quite easily change that to make it not equal to 0, to determine whether it's land or not. I'll also change the logic in determine terrain, not to use these constants, but to use the size of the array. Further down that function, where we determine whether it's land or not, and we set the height, I'm going to make the height equal to the offset multiplied by the terrain type. So where the land is 1, then the offset will be 10. Where the height is going to be 2 for hills, it will be double, and triple for mountains. Let's try running the application now and see if that's improved anything. Yes, our terrain map is now correctly showing at the edge of the 3D map that we're still in land. It's not going down to the sea level. So it would appear we've cured that little bug in the 3D terrain map. So we'll return the code so that it draws this map all at one time. And we will do that by putting back in the redraw command. So now that we've cured the bugs and set up the system slightly more flexibly, we can now look at injecting some mountains into the system. So once we've loaded a map array, we'll want to build some mountains. So let's look at the load map array function. So before we dump the array.txt file, we'll need to inject in a call to a new function called build mountains. Our function to build the mountains is not going to be a complicated one. We have a constant set up for the maximum number of mountains. And we're going to do a while loop to step through that until all the mountains have actually been positioned. We're using the random number function to give us a number between 1 and the map width and 1 and the map height. That will determine the coordinates on which we wish to put the mountain. So we need to test to make sure that the territory we have picked is not a C location. In other words, it is not 0. If it's land, then we're going to slot in a mountain. We will update the terrain to mark it as level 3, and we'll advance the counter for the number of mountains we have located. And we want to create some hills around this mountain. As you can probably guess from this code, we're not testing to see whether we've randomly picked a location which already has a mountain. This is a piece of code we can always add later. So let's now go and create the createHills function. This is going to do something very similar. We're passing in the row and column coordinates of the territory we have selected. So this is going to look at the 9 territories surrounding the selected territory. Obviously, if the territory is the one we're actually in, we're going to iterate to the next loop. We'll double check to make sure we're within the map width and the map height. And we will check to make sure it is not C. And I've added another random number calculation to give us a 75% chance of putting a hill beside the mountain. That way all the mountain ranges won't look the same. And if that passes, then we're putting the value 2 into the array. So if we run our application now, pick our map, open it up, and what it should have done, it should have created the array.txt file. And if we look at the array.txt file, we can see there are 0 for C, 1 for land, and there are some 2s and 3s appearing in the map. So we have successfully populated the array with values 1, 2, and 3. So all we need to do now is to display these on our map. So in order to do that, we need to pop into the draw polygons terrain function. And we're going to create another local variable called mountain, used to determine hills and mountains. And within our loop, we will default that to the value false. Further down the code, you'll see this line. This line looks to see if the offset is greater than 0, then the value of the C variable is false. We're going to be amending this to check to see if this is indeed a mountain or not. And we're going to do this for each of the vertices of our polygon. So we check to see if the offset is greater than 0, in which case it's not a C, and then we need to determine whether this is a mountain or not. So we're going to create another new function called determineMountain, taking 2 parameters. One for the value of the offset, and one for the flag, is it a mountain or not. This is because if any one of the 4 vertices of the polygon is greater than the value 1, then we're going to consider this to be a hill or a mountain. The reason for doing this is I want these polygons coloured differently to the landmass. So we're going to duplicate this code through the rest of the checks for each vertex, as the same check will be required for each. And at the bottom of this function, where we determine the colour of the polygon, we're going to put an extra condition in here. This will test our new variable long mountain. If that returns true, then we're going to use a different colour for the polygon. And we can take our 2 sleep commands out, as we don't want to slow the code down anymore. So we now have to create the determineMountain function. And here is our new determineMountain function, with its 2 parameters, the vertical offset and the mountain variable. If the mountain variable is true, then it's already a mountain or hill. Therefore, we return the value true for the function. If it's not yet a mountain, we're taking the height of the vertical offset divided by the vertical offset value. This quite easily gives us the value 1, 2, or 3 and tells us the terrain type. This will allow us to display the polygon correctly. So if we try running the application now to see how our polygons are looking. So we select the world map, and we'll process the first turn and click on one of the territories. And there is our 3D map now showing hills. The hills are showing in a light brown colour, the standard landmass, which is flat, is showing in green, and the sea areas are showing in blue. So if we pick another area, we can see we're quite happily getting mountains and hills. So our 3D terrain is now showing correctly and much more realistically. So in summary, what we've achieved today is we've added hills and mountains to our game map. We've amended the 3D routines to display hills in a different colour, so that they stand out visually for the user. In our next video, we're going to change the battle routines to allow the possession of a higher ground territory to be more advantageous to the defender. And we're also going to put some navigation controls on this dialogue to allow us to move around the graphics map without having to leave the dialogue. However, that's it for today. Thank you for watching.